Practice set 5.3. See first example. Write sample space S and number of sample point n of S for each of the following experiment. Also write events A, B, C in the set form and write n of A, n of B, n of C. So see the first question, sub question. One die is rolled. Event A is even number on the upper face. Event B is odd number on the upper face. Event C is prime number on the upper face. So here one die is rolled. When one die is rolled, then the sample space for one die is, so we write here S equals to, elements are 1, 2, 3, 4, 5, 6 because numbers on die or dot on die are 1, 2, 3, 4, 5, 6. So here n of S equals to 6. So write here number of sample point n of S equals to 6. Now first event is even number on the upper face. So we consider event A. So elements of this event A are 2, 4, 6 because 2, 4, 6 are the even numbers in sample space. So total number of elements in A are 3. So n of A equals to 3. Similarly, we have to find n of B, n of C. So we write here B equals to 1, 2, 3 because event B is odd number on the upper face. So odd numbers are 1, 3, 5 from the sample space. So we write here B equals to 1, 3, 5. So total number of elements in B are 3. So n of B equals to 3. Event C is prime number on the upper face, and we know that prime numbers start from 2. So 2, 3, 5 are the prime numbers. So write here C equals to 2, 3, 5. So n of C equals to 3. See question. Write sample space capital S and number of sample point n of S for each of the following experiments. Also write events A, B, C in the set form and write n of A, n of B, n of C. So see second sub question. Two dice are rolled simultaneously. So in first example one die is rolled, here two dice is rolled. So we have to write here sample space in order pair form. So see the events first. Event A is the sum of digits on upper face is multiple of 6. Then event B is the sum of digits on the upper faces is minimum 10. And event C is the same digit on both the upper faces. So first we write here sample space for two dice. So write in answer sample space S equals to in order pair form 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total number of sample point in sample space is 36 here. So we write here n of S equals to 36. So write number of sample point n of S equals to 36. Now for event A, sum of the digits on the upper faces is multiple of 6. That means we have to add these two outcomes 1 and 5, we get 6, 2 plus 4 we get 6, 3 plus 3 we get 6, 4 plus 2 we get 6. Then in this 5, 1 we get 6. Here 6 plus 6 we get 12, which is multiple of 6. So in this way we have to find those outcomes whose sum is multiple of 6, that is 6 or 12, because highest number is 12. So see here A equals to 1 5 2 4 3 3 4 2 5 1 6 6. All these elements we write in A. If we add them, we get 6 or 12. So see here, 1 plus 5 6, 2 4, 2 plus 4 6, 3 plus 3 6, 4 plus 2 6, 5 plus 1 6, 6 plus 6 12, which are multiple of 6. So total number of elements are 6 here. So we write here n of A equals to 6. Then second, the sum of the digits on the upper faces is minimum 10. That means after adding the numbers we get 10 or more than 10. We require more than 10, minimum 10. So first we observe the numbers whose sum is 10. So here if we see the last 3 6 we get 9. So we not consider this. 4 plus 5 9. So we start with 4 6. So 4 plus 6 we get 10. Then 5 plus 5 we get 10. 5 plus 6 we get 11. 6 plus 4 we get 10. 6 plus 5 we get 11. 6 plus 6 we get 12. So we consider those order pair whose sum we get 10 or 11 or 12. So write in set B 4 6 5 5 5 6 6 4 6 5 6 6. First we write all the numbers whose sum is 10, then sum 11, then sum 12. So total number of elements in set B are 6. So n of B equals to 6. Then for event C, the sum of digit on the both the upper faces, the same digit on both the upper faces, same digits means 1 1 2 2 3 3 4 4 5 5 6 6. So we write in set C the order pair 1 1 2 2 3 3 4 4 5 5 6 6. So n of 6, here total numbers, total elements are 6. So n of C equals to 6. Then question number 1, sub question third. 3 coins are tossed simultaneously. So we have to write sample space for 3 coins, and events are: condition for event A is to get at least 2 head. Condition for event B is to get no head. Condition for event C is to get head on the second coin. So first we write here sample space. So sample space S equals to E, 3 times H, 3 times T, then H H T, H T T, H T H, T H T, T T H, T H H. So we get here total 8 elements in sample space S. So for first condition, so first we write n of S is equals to 8. So for condition, according to condition for event A, to get at least 2 head, we require at least 2 head. That means first we select the sample point which contain 2 head, and then we select head more than 2. So see here, to get at least 2 head, A equals to H H H, that means 3 head, H H T 2 head, H T H 2 head, T H H 2 head. That means here we select those elements which contains 2 head and more than 2 heads. So total number of elements are 4. So n of A equals to 4. Then condition for event B, to get no head. That means we see here the elements, here last element is such that there is no head. So B contains only one element which is T T T. So n of B equals to 1. Then last event C is to get head on both on the second coin. That means we find only head on second coin, on first maybe head, on third maybe head, maybe tail. So see here, this first point we select, here we select, here on second position here is tail, on second position here is tail. So we select this element. Here head is at second position, here tail is at second position, so we cannot select this. Here head is at second position, so we select this element, and in last element there is no head, so we exclude that element. So see here, we write here H H H H H T T H H as the element of set C, because we required head at second position, and for all these three elements head is at second position. So n of C equals to 3. Now see sub question 4. Two digits number are formed using digits 0, 1, 2, 3, 4, 5 without a repetition of the digits. We have to form two digit number with the help of these 6 digits 0, 1, 2, 3, 4, 5 without repeating the digits. Condition for event A is the number form is even. Condition for event B is the number form is divisible by 3. Condition for event C is the number form is greater than 50. So first we form the two digit number, and we know that when 0 is at 10th place, then that number is not two digit number. So we take 1 at first position, 2 at first position, 3 at first position, 4 at first position, and 5 at position, that is at 10th place. So we write here in sample space S containing the numbers, two digit numbers 10, 12, 13, 14, 15, then 20, 21, 23, 24, 25, then 30, 31, 32, 34, 35, 40, 41, 42, 43, 45, 50, 51, 52, 53, 55. So here if you observe, we not write 1 1 because condition is without repeating the digits. We not write here 22, here 33, here 44, here 55 because we not require a repetition of digits. So here total number of sample points are 25, and for event A condition is the number form is even. So we select here even numbers 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52, 54. So write the number form is even. So set A contains element 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52, 54. So all these are even numbers and total numbers are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we write here n of A equals to 13. Then second event is the number form is divisible by 3. So we require the numbers which is divisible by 3 from the sample point in set B, that is in event B. So we write here the number divisible by 3. So 12 is divisible by 3, then 15 is divisible by 3, 21 is divisible by 3, 24 is divisible by 3, 30 is divisible by 3, 42 is divisible by 3, 45 is divisible by 3, 51 is divisible by 3, and then last this 54 is divisible by 3. So we select all these numbers from this sample space which is divisible by 3. So total numbers, that is total elements of set B are 9. So we write here n of B equals to 9. So we confirm 1, 2, 3, 4, 5, 6, 7, 8, 9. So we write here n of B equals to 9. Then event C, the number formed is greater than 50. So see here, we required number greater than 15, not 15. So we write here 51, 52, 53, 54 as the element of set C. So number formed is greater than 50. So the set C contains 51, 52, 53, 54. So total numbers are 4. So n of C equals to 4. Now see sub question 5th. From 3 men and 2 women, environment committee of 2 persons is to be formed. Condition for event A is there must be at least one woman member. Condition for event B is one man, one woman committee to be formed. Condition for event C is there should not be a woman member. So see here sample space. So we consider here 3 men as M1, M2, M3 and 2 women as W1, W2, or we can represent 3 men as M1, M2, M3 and women as female F1, F2, F3. So here 2 women, so we have to consider only F1 and F2. So see the sample space M1, M2, M1, M3, M1, F1, M1, F2, M2, M3, M2, F1, M2, F2, M3, F1, M3, F2, F1, F2. So the total number of sample points, that is n of s equals to 10. So see the first event, there must be at least one woman member. At least one woman, that means 2 women can be selected. So see here, we write the elements of set A as M1, F1. Here one woman we select, that is F1. Then M1, F2 we select second woman, which is F2. Here M2, F2 we change the person, instead of M1 we consider here M2. Then M2, F2, M3, F3, M3, F2, F1, F2. So we skip here this first element M1, F2 because both are men, M1, F3 because both are men. So here we skip first element, second element and this element M2, M3. Here also both are men. So we eliminate these 3 elements. So we get remaining 7 elements which contain one woman or 2 women. So n of a equals to 7. Then condition for event B, one man, one woman committee to be formed. So we have to select those members in which committee one woman and one man include. So M1, F2, M2, F1, M2, F2, M3, F1, M3, F2. So these elements, 6 elements contains one man and one woman. So see here B equals to these 6 elements we write, which include one man, one woman, one man and one woman. So n of B equals to 6. Then for event C, there should not be woman member. So we have to select only the committee of men members. So right here M1, M2, M1, M3, M2, M3. So n of C equals to 3. Then last sub question, one coin and one die are thrown simultaneously. Condition for event A is to get head and an odd number. Condition for event B is to get a head or tail and an even number. condition for event C, number on the upper faces is greater than 7 and tail on the coin. So see the sample space. Here one coin, so we get head or tail. One die, that is 1 2 3 4 5 6. So we write here sample space as H1 H2 H3 H4 H5 H6, then T1 T2 T3 T4 T5 T6 as the sample points. So n of S is equals to, we get 12. Now see the event first, that is event A. To get head and an odd number, so we select here the head and odd number, that is 1 3 5. So we write here H1 H3 H5 as the sample point, element of the event A. So H1 H3 H5 satisfy the condition that get head and an odd number. So head odd number, head odd number, head odd number. So total numbers are 3. So n of A equals to 3. Then second condition is to get a head or tail and an even number. That means we can select any head or tail, but number must be even number. So we write here H2 H4 H6 T2 T4 T6, because here numbers are even, and in first three first is head and in last three first is tail. So we write here to get a head or tail and an even number. So H2 H4 H6 we get head even number, here we get tail even number. So n of B equals to 6. Then last, number on the upper face is greater than 7 and tail on the coin, and we know that here we get number up to 6, 1 to 6 on the dice. That means there is no number greater than 7. So we write here number on the upper face is greater than 7 and tail on the coin equals to no sample point. So here in this sample point there is no such sample point. So we write here no sample space exists for this event, as dice does not have number greater than or equals to 7. So n of C equals to 0. So in this way we solve the questions of practice set 5.3.